to LangGraph. Okay? So LangGraph, when it comes to LangGraph, try to focus on LangGraph if you are working on any of the capstone project. But don't limit yourself only to LangGraph. If you feel like using Crew AI, Semantic Kernel, AutoGen, you can use it. But my preference would be to use the two framework, the LangGraph and Crew AI, because the Semantic Kernel and AutoGen, I'm just trying to show you using the Azure OpenAI. So you need an access to Azure OpenAI key, which is maybe a problem for you, but I don't want to limit yourself. If you want to work on using this, I would say the open source key, you can also use it within your semantic kernel in AutoGen. But if your use case demands, okay, otherwise don't work. But just giving you, the idea of this framework is to, so that if you want to switch into the industry, it will be easy for you, because in an interview, they may ask you that the framework, it's not limited to LangGraph or QI. They may ask you related to AutoGen and semantic kernel because of the evolvement or whatever you see evolution of CRM tools, because more of the CRM tools they use this semantic kernel, okay, for their orchestrations. So that is why the semantic kernel is also important. Don't look it into isolations, okay? So now I'm just giving you walkthrough of this, what you all people have gone through in this entire this so to say, this summer training. So I'm just trying to connect the dot so that you all will be in this same plane, right? So something which you might have learned, and this is called LLM, right? And from LLM, I was assigned to give you informations, knowledge about this agentic AI, right? So connecting a dot from LLM to agentic AI, it's again, you might have a beautiful journey till now, right? So, at least 4 weeks, I think it's again, you might have gained a lot of informations, and it will help you also, right? Because the kind of informations we people have given you will not find it any place, because it's more of a industry oriented, right? And the LLM that right, something you might have gone through, something called retrieval augmented generations. The second one is the RAG one, right? So RAG, I think you people know it, okay? So LLM, right, RAG. The something that I have covered is AI agent, agentic, and MCP, right? So I think these three, now people are moving from RAG to agentic AI. The reason for moving is, again, a kind of autonomy you want, right? You want your application uh, to be more autonomous, even your institution, right? It's autonomous, I think, right? So you all need an autonomy. Why, as a human, we need an autonomy? The reason is that we want to grow, we want to explore, we want to experiment, right? That is why we need an autonomy. So whenever you try to understand any of the AI concepts, try to bring parallel with the human psychology, okay? Because that will give you more clarity. If I say my AI agent will take actions, take decisions, and I want my AI agent to be autonomous, you just compare it with the human. Why my AI agent needs to be autonomous? Why? Right? So this is what you need to think through. Okay. So let me share one more screen. Just allow me 30 seconds. Just a minute. Where I was. So can anybody tell me what is a rack, Yugratna, or anybody? What is rack?
So RAG stands for Retrieval Augmented Generation, and it is basically used to provide the answers from the stored data.
From the stored data, right?
Yeah, so it has two parts, like retrieval and then generation of the data.
Okay. Retrieval and
Retrieval and then generation, like it's retrieval augmented generation.
okay.
And it has various steps, like first the data loading takes place, then the chunking of the data takes place, then it is stored
Mhm.
in the form of embeddings in a vector database, which can be maybe a chroma db, and then we give in a prompt which the llm again converts it into vectors, and then it matches with the most appropriate answers from the database, and then the llm again converts that answer to human readable language, and then it gives us back the output.
Yeah, good, good. My computer doesn't have space. What is happening here? 1 minute. Okay, your answer is right. So, but for RAG, what is the bad part of RAG? What is the disadvantage of using this RAG? Is there any disadvantage if you compare it with?
So it cannot give us the current information. Like it can only give us the information which we have given to it.
Mhm.
So
Mhm.
since it cannot use tools like web scraping and stuff, so it cannot give us the current information that is right now over there. Like there is a cut-off date till which it can give us an information. Also, it might lead to hallucination if a question which has not been given to it is asked.
Yeah, right. You're right. Right.
So
Right.
also if proper chunking is not done, it can lead to like
Mhm.
weird answers.
Yeah, right. So, I mean, to get some grounding response, right? So you need this one, right? Yeah. Okay. Mm, there is some issue with my access. 1 minute. Let me still try to share my screen. It's like so weird. Yeah, let me show this. Can you see my screen, right? I was able to open like this. Okay. So, I mean, so when you use this AI, right? So, uh, the questions that this Noel Harari is asking, that what happens when non-human intelligence hacks the operating system of civilizations, right? This is again a questions that you need to think through, because you work on AI agent or agentic AI because you're giving some autonomous power, right? So what if your agent start taking decisions, right? A non-human intelligence. So it's again an agent, right? He's talking about, okay? So what if hacks the human civilizations, right? So what will happen, right? So there are also few terms that he has used. So you will see these terms coming because of this agent, because agent talk to you, right? So that is the beauty of this agent. But again, there are also a downside of it. There is a bad side of it also, because something that you see as a revolution can also backfire, right? So don't look at the golden side of agents, AI agents or AI, but there is also some of the bad side of it, okay? Because if you want your civilizations to thrive, grow, you need some kind of a check and balances. You need to have some kind of a guardrails. You need to have some of the ethics in place. Some of the agents that you create, behave responsibly. That is why this responsible AI, ethical AI, right? uh, that comes into play, right? So it's not think through like, you know, uh, we are moving in a right directions, but we also need some check and balances, right? So this is what I'm trying to explain. But again, let me come back to my original slide and let's start from there. So yeah. So quickly, let me go to this screen. Hope. Yeah, hope my screen is visible, right? Just confirm it. Okay. So now this slide I'll explain you again so that it's just covering every single thing, right? And then we'll switch to some, semantic kernel and autogen. We'll add, you will solve some of the use cases, right? So this is what I plan today because it will cover all your 4, 5, whatever agentic AI systems, right? So I mean, you all know this LLM, right? So we have some of the prompt that you give and then you get a response back, right? So this covers your LLM part. So this is your LLM. You just give a prompt, you get a response, right? So this is the task of the LLM. So why people are after this LLM? Because it gives you natural language response that human can understand. So that is why we are after some of the systems which can at least talk like humans. So we humans somehow able to experiment and create an LLM for us. But what was the bad side of LLM? As you already told, right? It doesn't give you real-time informations and also cannot take actions on our behalf. So these are the two things that LLM lacks. So how you can make your LLM smart? So that is why this concept called RAG came in. People have developed this concept of RAG. At least we are giving some informations to LLM that, okay, I'm giving you a book, I'm giving you some extra informations, some external informations. You just look at those informations, look at those data and give me the response back like a human like response, right? So, I mean, this LLM, we have added some of the data source, right? This data source to LLM. So now LLM has more visibility to by looking at this data, right? So the LLM has significantly improved themselves. And now we are seeing this RAG because we are exposing our LLM to external data sources, right? But again, the problem is still not solved. We are still not able to take actions. You may are getting, maybe you are getting some real-time information in RAG, possibly, but still my application, my AI system is not taking actions. That is one of the biggest worry for us because to we want to work on a systems that can take action my behalf. Is it taking this RAG will take action on our behalf? Can anybody answer? So RAG will not take actions, right? So again, when it comes to your AI agent, so if you see this AI agent, okay, it will take actions. Okay. So for example, now we are giving access to some of the APIs and tool. So these API and tool are giving some, hands to your LLM that, okay, you take actions now because whenever we take actions, let's say kind of a fight, right? We use our legs and hands, right? So now these APIs and tools are nothing but legs and hands to the LLM so that it can at least participate in a fight. But right now, it's not like a fight. It's like actions. Action could be good or bad, both. How we are trying to configure our agent, what we are trying to say our agent to do. That is why Noel Harari was saying that if your agent take actions, right? So what will happen to the civilization? Just think of it, right? The same thing, how you're trying to train your AI agent to behave, right? So sometimes your tool may backfire, right? But also you want our LLM to take some actions for right reasons, for good reasons, right? So this AI agent is something, a systems which can take actions on our behalf. But when it comes to agentic AI, the multiple agent trying to achieve a single goal. In that case, you need something called orchestrator, right? There is something called orchestrator. And there are different agent, second agent, third agent, fourth agent. And if there are multiple agent trying to achieve a single goal, there might a case of happening some of the conflicts. Okay. How these conflicts you can solve. So even in organizations or even in your, university, there are some of, the people who are, you can say the dean, director, right? So they are the people who are responsible for coordinating you people because how people, how people can manage 200 students. So just think of 200 students like agent, 200 agents working for a single goal and without any orchestration, without any manager, is it possible? No. We need someone to take care of. They can divide the task, delegate the task. That is why this agentic AI needs some kind of a collaborations, coordinations, orchestrations, kind of a margdarshan, right? You need some margdarshak, right? So those frameworks, agentic framework, if I say, like LangChain, Semantic Kernel, AutoGen, Crew AI, are the orchestrator, are the manager. are the coordinator, are the collaborators. Because now we are trying to implement multiple agents together. So these agents will talk to each other. We cannot let our agent work in isolation. We want to work under some umbrellas, right? So this is the all I'm trying to explain at the concept level. So whenever you see agent, AI agent, RAG agent, don't get confused. So this slide can help you better understand these concepts, because when you start working on any of the use cases, it's good that you can work on because the code and everything is available. But at concept level, if you are able to make your interviewer understand that, okay, this is my thought process when I say AI agent, what I'm trying to understand it, right? So don't give us the bookish language answer. It's fine to give the bookish language some definitions and everything, but if you are able to interpret it in your language, come up with some beautiful examples, it can serve your purpose, right? So this is what I'm trying to explain you in terms of this LLM AI agent intelligent. Any questions so far, anybody?
No, sir.
Everything is clear, eh? Okay. So let me share my one more screen where I was just um, it's Semantic kernel. Let's see if just give me some seconds then. Okay. Oh, my screen is visible, right? Is it visible to everyone, right? So
Yes, sir.
we'll see this semantic kernel and autogen because these are two important agentic frameworks. So when I say agentic framework, it is again I'm talking about coordinator, collaborator, manager, orchestrator, because I will be handling multiple agent, more than one agent. That is why you need a framework. So when you say a framework, it means we need someone who can give margdarshan, right, to your applications, right? So uh, whenever someone says agentic framework, look at the perspective of he's here talking about multiple agent talking to each other, more than a agent, right? So if there are two agents, we need a framework. Cannot let your agent work in isolation. You need a framework. Within that framework, he or she will work, right? So this is the agentic framework typically, right? So semantic kernel, we'll see that how this semantic kernel typically works. But again, we'll look at the few concepts and then we'll jump on to the use case, right? We'll see the coding part because that is more important, that how you're trying to implement it, right? So there's something I was just trying to explain over these weekend or all those classes. So when you say an agentic AI, it's like LLM that reason, plan, use tools, and collaborate, not just answer a single prompt. So whenever your system is answering a single prompt, it's like a simple chatbot. A simple, we interact with your chat GPTs. But when you have this AI agent, you have some LLMs, tools, memory, some of the orchestrations, right? Also, there is something called, autonomous agents that we were talking about, whether my agent can take decisions autonomously or not. Because why you need, to take your agent autonomous decisions? Let's draw a parallel with. There are situations in our life where nobody teaches us to take decisions, because there are some instances, circumstances, situations where we are taught to take decisions because we are trained like this. But there are some occasions where we are not trained to take decisions, how we can take decisions as a humans. So whatever we have, these historical experiences, based on that we extrapolate, interpolate, and imagine and extra, put some reasonings, and then we take decisions. So that is autonomous decisions. Something which are not in your template, something which are not in your rule book, and then you take decisions. So the AI agent, if they are not taught to, if they do not have given some instructions, still they are taking decisions based on their intelligence. That would be the beauty of autonomous. Na? Otherwise, if I'm feeding a child that if this situation comes, take these decisions. If that child is unknown to, not familiar with the situations, will they take decisions? No. So that is why we need an autonomous agents. If they see some of the unfavorable situations where they haven't seen this entire systems, still they can take decisions. That is the beauty of AI agent. And that comes this autonomous part, right? Try to understand that. Okay. So the framework that we were talking about, multi-agent orchestrations, planning, guardrail, observabilities. Okay. So semantic kernel is enterprise level orchestrator, and they use these plugins. Plugins is nothing but it's kind of a tool, but they are specialized plugins. Other, framework doesn't give you this access to. Okay. Then it comes to autogen. It's conversational multi-agents. Also, they have a collaborations like because they will orchestrate this multi-agents and they have a lot of autonomy, right? So when you say they have this autonomy, okay, so I mean that is the beauty, na, right? So they can take some decisions. We are not spoon feeding the entire systems. We are letting our agent to take decisions autonomously, right? That is the beauty of. So there are a lot of institutions, they are autonomous. Why? Because government cannot feed the entire, you know, university or colleges to behave like this or do this like, something like this. Otherwise, productivity will decrease because for every single time they have to reach out to the authorities and they will take permissions and then they will execute it. Is it possible? No, right? So that is why we want our AI agent to behave like autonomous agent so that they will have a lot of autonomy and they can execute the task and it will be faster, right? So that is why we are looking for some of the agentic framework where it has more autonomy, right? So now, where we can use this semantic kernel again, because when I say semantic kernel, right? So, I mean, there would be some usage of, and the beauty of this semantic kernel is that it is, again, you can use it with .NET framework and C Sharp, even with the Java, right? So that is why across the industry, you'll see if there are people from C Sharp, right? Or maybe the Python is like the golden, the programming language for the AI people. But if people are not from the AI, working on some other another tools, so Java people, if they want to explore this agentic framework, better to go with the semantic kernel because this SDK is there, right? So that is why this, semantic kernel, in some cases, surpass this LangGraph because of these plugin facilities and the language. They do not have the language barrier. At least they have, people can use it in some other language as well, right? So now there are a few core concepts. When you work on this semantic kernel, you have to have and you come across different, these concepts basically. So we'll see these frameworks one by one. Okay. So there is something called kernel. Okay. So when you say kernel, what we refer to, right? So I mean something which we are referring to some divisions or something or what? So kernel is nothing but it's like a main orchestrator, main manager, main coordinator, main executor. Okay. So they're gonna wire everything. They will connect dots to everything. They can package it to everything and then pass it to your LLM. So that is why you need a kernel, a central point, a central nervous systems. Okay. So if your agent has capability of adding all those dots, package it and pass it to your LLM, it's good, right? So that is the main use of this kernel. Okay. Now, second point is your something called, if you see this one, you have something called AI services. Because a kernel is behaving like a tool, but we need one LLM. So, in your any agentic systems, the formula that I was given you is AI agent equal to LLM plus tools. There are also something called memory instructions that you can give, but broadly, when you think of any agent, it's like again MCP plus some of the tool facility, extending facility to some of the your LLM too, so that they can take decisions, actions. Otherwise, LLM is like isolated persons sitting idle on a chair, thinking too much, but not taking actions, right? So you want your LLM to take actions, right? So AI services is again you need an LLM. AI, when I say AI services, it's like a LLM. You're giving LLM to the kernel. Then we have something called plugins. Okay, plugins and functions is like if you have some of the tools, specialized tools. Prompt is like you write some of the semantic prompt. I'll show you that how typically you write semantic prompts. So plugins plus functions, you consider it as a tool because we're extending this LLM plus tool. Okay, both together. And kernel is the orchestrator, main orchestrator. So it will orchestrate AI, LLM plus tools together. And if you add this memory to memory plus planner plus telemetry. Telemetry is again observability. Okay. So these all things will create an AI agent all together. Okay. So if you go with this planner, this is auto compose functions. Okay, and this will decompose your prompt. Because if I say book a travel plan from Goa to maybe from Bangalore to Goa, so they will divide it. So who will divide? It's a planner. Okay, they will divide the task to achieve that goal, right? And a telemetry is one of the tool that will also log your how your system is typically behaving, how your LLM is behaving. It's like a observability, a log capturing that how your system is robust or not, whether it is failing in your productions, if it is failing, what is the reason of, because as a developer you will look for the log, that what log says, and then you work on your improving your entire systems, right? So that is why this and part you don't look at the isolations, because you will need some of the observability tools to integrated in your AI systems. Because if anything fails, where you will capture the entire history? It's like a black box, right? Of your aeroplane, right? So if anything happens, you can retrieve what has happened inside this black box, right? So that is why if the plane crashes, people look for this black box to get the idea that what has happened, right? So the same things happen with this telemetry. It's like a black box for us. Gives you this observabilities, logging informations, something which has happened entire journey when your applications are inside this production grade or dev or whatever you call it, right? So this is what entire semantic kernel, the core concepts are, right? So now let me move to clear my drawings. Let me move to the next slide, 1 minute. So if you see this kernel architecture, again, we have some of the services, right? So AI services, the applications, let's say we have written our application in Python because it's, for AI people, we have written this application in Python and hosted it, right? And how my application will interact through this kernel will have access to a something called AI services, will have a tool calling facilities, will have a planner and memory. All these things will make this agentic AI. 1 minute. Just allow me 1 minute. Yeah, okay. So So you have this, orchestrator, and within that orchestrator, how this kernel typically work, will have access to your AI services. You can create plugins and functions. You'll have access to planner because whatever prompt you are giving to your AI systems needs to be broken down into subtasks, and subtasks will get divided to the tools that they are associated with. Because once the task is divided, then you will map that task that this person will do. That is why planner comes. And this memory is again kind of remembering your old historical conversation, so that if you ask any questions, then it will lead you to the connected answers that you have asked these questions earlier, so now I'm giving you a response from there, right? So this is what memory and connectors typically do. And then we have this LLM and this vector stores to give access to this memory, and LLM is again for this AI services. Okay, so this is what all of you can say the part of the architectural diagram typically looks like, when you work on this semantic kernel. Okay, so let me move to this uh, something that we have seen in this PPT. So the prompt, when you say prompt, it is something called semantic, because it's like in a natural language, right? Whatever you try to write it, it's in natural language, right? And we call it a function because we want some template. We do not want to change it, right? Because if I'm trying to change, prompt every single time, we are not working on a production grade agentic AI systems where, every single time we have to tweak in the prompt, right? So we need to have some of the prompt fixed, a template based, where we can call it whenever we require it, right? So that is why this word prompt function is used. Okay, so whenever we want to call it, where, okay, so this function word is used in the Python. We can call this prompt semantic functions, so that whenever you require to call it, we can call it within the functions, right? And something called native functions. So in the Python, also will see that the few native functions. Okay, so again, we use a decorator. In Python, there is something called decorator. So add typically we use, okay? And then the third point is a plugin. So it's nothing but it's a group of functions, okay, that kernel can use. Because if we are giving kernel, because the kernel will decide what functions to, what plugins to pick, right? And then we have auto function calling. It's like LLM to delegate that the which tool to pick, right? So these are the sum of the steps when you work on this semantic kernel, that the few of the components that you have to understand. In the Python programming, it is nothing but it's a more of a function calling. You'll see different functions. But if you look at the architectural perspective, you'll see, uh, I mean, these are nothing but the component of semantic kernel, where semantic is more of a, again, a functions, writing a good prompt, which we can call it again and again inside your applications, right? So that we typically call it as semantic functions. Okay. So now let's look at this program perspective, that how we can create this entire applications and work on that. Okay. So let me stop sharing my screen and let me walk you through this code part first. So hope it works for us. Where I was. This.
Excuse me, sir.
Mhm.
Can you explain native function once?
Which one?
Native functions.
One minute. Let me share my screen. Let's see, less space. Let me share my screen. That can you see? So
Yes.
when it comes to native functions, for example, it's like a again first concentrate on the word called function. So in the Python, typically we how we write a functions, right? So at or like a def. If you see on the right side first, the code snippet that I have attached, I'll explain you the code. Okay. So if you see this one, this is a decorator functions. Okay. Okay. Within this class, help desk plugin. This is a one class, and within that we have defined one functions. Okay, this is a decorator functions. Within that we have get ticket status. Okay, so when it comes to native functions, it's a normal Python method. Okay, so what is method here? If you see this one, you'll have this help desk plugin. Okay, this is now a method now. Okay, so at kernel functions typically we write, and within that whatever you are saying is a native functions. So ticket ID we are fetching. It may be from some of the data sources we are fetching. Self, okay, because we are trying to call within this class. So whenever you call anything within this class, we use this self because it is referring to your object will be referred to. So ticket ID, let me show you the code, okay? And then we'll understand what is ticket ID, okay? So native function is something which are very much you can write it using your Python libraries. That is your native functions. But there is something called semantic functions. It is like whatever you can write it in natural language, okay? Yugratna, you have asked me, right?
Yes, sir.
So when it comes to native function, this is your native function, entire block. Okay. But when it comes to semantic function, we will write it in like a prompt. So let me share you. Okay. 1 minute.
Okay, sir.
Where is because there is some space issue with my laptop, so I'm worried right now. 1 minute, 1 minute. Where my screen is? Is it this screen, right? Can you see my screen, right?
Yes, sir.
Yeah, just see this one. So this is one use case that we have created using this. Oh, 1 minute. Let me stop saying 1 minute. There's some. Just give me 30 seconds, then I'll share my screen. VS Code, right? I was in VS Code. How to cross it? What? Cross. Okay. I have. Okay. Let me share my screen. Sorry. So what we're trying to achieve, and then I'll explain the code. Okay. So this is one small use case for semantic kernel. So this is the use case. First, understand this use case, what we're trying to achieve. So autonomous IT help desk, we are trying to create one agent, and it's a single agent and given access to tool, right? Because single agent alone cannot do this help desk task because they need to access to some of the data sources, some of the information, so structured or unstructured. Okay. This shows a real agent. The LLM is given a set of native Python functions. We will work on what is native Python function. We'll see, and it decides on its own which tool to call and with what arguments to answers the request. This is called auto calling functions. Okay, there are three things. One we will see with this semantic, native, and auto calling. There are three functions, and what we are trying to achieve and create autonomous IT help desk, which will give me the response depending on my ticket, my concern, right? So this is what we're trying to achieve. It's using this semantic kernel. Okay, so this is again how we are trying to achieve async and OS. This is important. You can say, you have this module, Okay, will require this async. The reason for async is that if you want your agent to work in parallel, then you need this async. Otherwise, we can use it with the syncing, where one agent will work, then other agent will work. Okay. Now, coming to the semantic kernel, so let's go with this requirement.txt. If you go with this requirement.txt, I'm using only one Python library, that is semantic kernel. So you might have seen somewhere in my PPT it was written Python SDK. So any of your agentic framework, if you are working, look at their SDK, Python framework, Python libraries, because otherwise you cannot integrate it in your Python script because you need SDK, software development kit. So every agentic framework, if you are working with this Python script, need to have this SDK facilities. That is why we are using semantic kernel libraries here. Okay. Now coming to this our Python script. So these are the libraries modules imported from our semantic kernel. Okay. All these things. If you see coming from semantic kernel. What all I need? One function calling is required. The one that we are saying for auto function calling. We need connectors. Why we need a connectors? If I hover it, it's again a module because we need access to LLM. That is why we need this one. Chat completion, everything, because we are using this Azure OpenAI LLM keys. So that is why you see this module here. Okay. Now I think this is clear for you. Now if I go down again from the semantic kernel, if you hover it, it's a module. What it is importing? The chat history. Okay. The kernel functions. So this is your kernel functions. This is, you can call it as a native functions. Okay. So if you see function name descriptions, so this is more of a native functions where we can tweak in, right? So this is what the native functions typically. Now, if I go down, these all dependency required. This is a hard coded one. Okay, I just wanted my, I wanted to create only one script so that you don't get confused. So I'm using this hard coded environmental variable and putting it into single Python script. Otherwise, I would have this .env, which we have seen earlier coding as well, right? So what all I need to give access to so that I can create this semantic kernel, Azure OpenAI endpoint. Okay, so this is Azure OpenAI endpoint. I'll show you from where I'm getting it. Azure OpenAI deployment, Azure OpenAI key, Azure OpenAI API versions. So let me stop sharing my screen. Just look at all these things. Okay, first, four things I require, and from where I am getting it. You people are confused, right? From where I am getting it. Got it? So now let me show you from where I am getting it, so that it will be clear for all of us. Where I should go? Where I should go? Nowhere, right? So one it. Just allow me. What has happened? Just give me 30 seconds. Let me connect with Azure. Otherwise, phone template 1 minute. Azure OpenAI. QR code. I'm just connecting this Azure one. So just allow me some 30-40 seconds. Just let me connect with Azure, then we will carry on. This open, allow connecting with the device. So let me share my screen. Where I was, yeah, this one thing. Yeah, right. So one, two. This is screen. Share my screen and this one, yes. Can you see my screen, everyone? Just confirm it, okay? So, is my Azure screen visible to you, right?
Yes.
Yeah. So there are a few credential that I have used in the semantic kernel, okay? So from where I have used, just try to understand, okay? So I'm just trying to show you that I went inside this Microsoft Foundry. Within this Foundry, okay? If you go and just create it, okay? So let's say I have created one resource, RG. So this is the resource that I have created, okay? And I'm saying Foundry. Okay, and East US, okay, and just hit this review and create, okay. So once you hit this review and create, it may take 30-40 seconds first. Okay, and then just hit this create. So once you hit this create button, you'll see a screen. Let's see where it leads us to. So if you see this screen where this will show you this deployment is in progress. It may take some 30-40 seconds. Let's wait. Deployment is still in progress. Let's wait. Okay, it's completed. So go to resource now. Okay. If you go to resource, you'll see a screen like this. And if you go down, they are saying to build this advanced AI capability. So whatever RAG or whatever you see, agents and everything, you can create it here. So let's go to this screen again. So if you go down, just hit this go to Foundry portal. Okay. So if you go to this Foundry portal, okay. So this will let us to one of the screen. This is a new screen, Foundry, but let's go to older version. Just click it, just toggle it back. Continue without feedback, just do it. Okay. So if you go down, you'll have older Microsoft Foundry screen, which will look like this. Can you see this API key, right? So we are not interested in this API key right now. And if you see this project endpoint, okay. So let's copy these two things from here. I think my text file is not visible, right? Is it? Something which are visible now. Can you see my text file?
No, sir.
Okay, good. If you are not seeing, then it's good. Okay, just I'm copying these keys, that is it. And this is a project ID. Okay, so two IDs that I have copied. Okay, this is the project ID and the keys that I need to connect with this my Python script, right? So these two things I require right now. Now, if you go down the left side, right? So you have something called agent templates, fine tuning, right? A lot of things are there. We are not bothered about here. We need to have one model endpoint. The reason is that I need one LLM, okay, to have access to. And this Foundry, API keys kind of it is giving me the entry to letting me inside your home, and then I can go to the kitchen, something like this. So to go to the kitchen, I need this model plus this endpoint to eat something, right? So I mean, if I go to this model endpoint, and then there is something called deploy base model. So this will give access to your entire applications, whatever you have written it. Okay. So, I mean, then there is something called select model. Okay. So if you see, there is a word called inference task. In interview, people may ask you, what is inference task? So what all you can say, inference task. Audio analysis is also inferencing task. Something uh, which you take output from your LLM is inferencing task. So it could be audio analysis, audio generation, C. A lot of chat completion is also inference task. Completion, content filtering, right? Custom extraction, everything is inference task. What you want your LLM to do, that is inference task. Got it? So now, let me go down. I need a chat completion LLM. I need a model. There are 184 model what I can access to, and that can, if I need one of the LLM that can complete auto chat or chat completion can do that. Why I need a chat completion LLM? Because I want human-like response. That is why. So let me go down. There are different GPT model for me also. If you want audio generations, text to image, I can use GPT, this one also, right? So a lot of things are there in terms of LLM. So I'm looking for GPT 4.1 that I typically use, 4.1 mini, okay? So this is chat completion and a response that I want from the LLM. So it will do this chat completions and it will give me the response. Both things can be done. For example, if I give prompt to my LLM or AI system or agentic AI, so this will come under chat completions, but response also we want, right, from the same LLM. So that is why we are using provisioning this GPT 4.1. So if you go this 4.1 LLM, so there are a lot of things are written about this LLM. So if you go, what it typically do, everything is written. If you go their capabilities, what is their capabilities? So everything is written. The use case, what you typically do, execute it, pricing, technical specifications, everything is there, right? So what you have to do it, you have to just confirm it. So once you confirm it, you'll have a screen like this where the model version is very much important, that it gives you kind of a cutoff date, how much capacity of this model is. It can handle this 2050, 250,000 tokens, 250,000 tokens it can handle per minute. Okay, the content safety that people were talking about, it's like putting a guardrails. So there are some defined guardrails in default version 2. And the resource where this model is East US. If you go down and then you say hit deploy, okay? So my model will be deployed, because once it is deployed, then I can use their keys and the endpoint. So if you see this one, it is giving me the key, right? And it is giving me this endpoint. There are two things, okay? So I just go to this key. This is model key. Where I was. So let me just copy it. It is a model key. Model key. It will not be visible to you. Just copy and pasting it here. And then there is something called a model versions. So model version is GPT 4.1 mini. Okay, Control C. Let me share you something. So just wait. because of the key. This is the model. 1 minute, then I'll share my screen, don't worry. This is the endpoint, okay. So we will be using this endpoint. Okay. There is something called model version, like versions. Okay. So let me share my screen again. Okay. Screen is not visible to you people. If I share my screen again. So what we need this API and the key to have access to your model. That's all. Okay. So if you go in the new Foundry, you'll see a screen like this where more of the agents are typically we work on the agent. Okay. So let me stop sharing my screen and share this VS Code. 1 minute. So if I go to the VS Code, if I go here, I was stuck here because I need Azure OpenAI endpoint and deployment name, OpenAI key, and API versions I need. Okay, the 4 things I typically require. Okay, so if I pass these things, 4 things, okay, our work will be done. Okay, so the 4 things I'm just pasting it here. Okay, so I need this Azure OpenAI endpoint. So cognitive searches azure.com. It looks like this. So I'll go here and I'll see whether this model looks like this or not. Okay, cognitive search. Okay, controls and where I was. I'll just copy paste here. Okay, copy paste here. Okay. Then we have Azure OpenAI deployment, which I have also taken from this Azure. So I'll use this GPT-4.1 mini. I think it is the same. I'll copy it. If I go here, GPT 4.1 mini is the same thing, but again, let me copy it here. We'll see that if some error comes. Okay. Then OpenAI key is there that I typically require. So I'll go and grab this OpenAI key, whatever I have, this model key. So I have this key. Okay. So let's go to this key part. I think the key looks fine. Is it 1 minute? Key. Okay. Just pass this key. And this is something called API versions. Again, I'll go because I have copied this API version. So this version, I'll copy it and I'll paste it. So let's see if the same version, I think, but again, let it. Yeah. So if you copy it, just control V. Okay. So now what we have done, we have given access to our LLM, okay, to semantic kernel. This task is done because without the access of LLM, semantic kernel cannot orchestrate, right? So that was the one challenge that we have given to everything we have passed. Now, if you go down, there is something called tools, right? So if you see this plugin, okay, so the tool the agent is allowed to use is each kernel functions to become a tool. So whenever you write this at here in semantic kernel, it will behave like a tool. So it will fetch your ticket status because if I pass prompt that, this is my ticket. For example, if you go down, this is hard coded one. So I'm also giving this ticket information, ticket 1 and ticket 2. So it says in progress, assigned to the network team and ticket to resolved, okay, right now. But if it is connected to data source, it can give me the information. So what all we are fetching? Ticket ID. Okay. So this semantic kernel functions will fetch ticket ID, and based on this ticket ID, if I pass this in my ticket ID, it will fetch this entire informations. Okay. So now if I go down, there is more semantic functions. That is a kernel functions. Okay. So this will trigger the password, reset the username and everything. This is another functions. Okay. Check whether the internal company system service is available online or VPN email or something. So you'll see a lot of functions and plug in together. Okay. So we have a three, kernel functions. Okay. So this is also kernel 1, 2, and 3. Okay. So one is for trigger password, one for checking whether internet company system service is online or not. And third one is look up for the current status of the support ticket. Okay. Now we need all these three, kernel needs kind of a orchestrator. So if you go
Excuse me,
down, yeah.
so all the three functions would be native functions as well.
Yeah, these all are the native functions typically. Okay. So if you go down, these all are native functions. Okay. Because within this class only, we have all three functions. Okay. So these all are the native functions.
Yes.
So if you go down, now we need a kind of an orchestrator. We need if you even go down, where it is. So now we have defined these kernels. Okay. So kernel and the functions. Now we need one LLM. So whatever these people are doing, these functions are doing, must pass through the LLM because we need some human-like response. Okay. So these three native functions. Now the output will go to this LLM. If you see this one, this kernel is orchestrator. Okay. And this is our LLM. Okay, if you see this LLM, so our all data, okay, is passing through this LLM. Okay, that is why deployment endpoint API key and API version that I have passed. Okay, so it will work in asynchronous manner. That is why this def main asynchronous is there. Okay, so once we have given access to kernel, this will orchestrate. So kernel is here. It's again your class, but that is your variable assigned to this method. Okay. So now if I go down, we need to add this plugin. Means it is kind of for orchestration we are adding to, because kernel is the main guy who will orchestrate. That is why we are adding add plugin. And the plugin that we have created, user defined plugin, was this native plugin that we have created, help desk. The name of the plugin is help desk. Turn on automatic function calling, the one that we were talking about. Sometime it will invoke it to itself. We are setting it to something like this. And there is something called chat completions, Azure chat, because we want to have interface like a chat. So this is a variable, and you have this method. Okay. Now, if you go down, keep a conversation history to agent remembers earlier terms. Just we want your application to remember a kind of a chat history. So this is again a variables, and this class is there. Okay, how we define it. And this is user query, let's say. Okay. And now we are giving, the entire, you can say the access or response, whatever LLM will take. Okay. So if you see this kernel we are passing, because this is the main orchestrator. Okay. This will call your LLMs, tools, and everything together. And this should be there so that it can run and give you the response, right? So control S, do this control S. And if you go down, let me run it, Python. Let me see if it is written or not. On the same usually, okay. Let me run Python. Is it I should take some other terminal, right? Let me take another terminal for now. Then we'll go to the okay, because I have changed it. Okay. So okay, it's entire VS code. sorry, it's in virtual environment is created. So now what we have to do, just whatever is written, this is main script only, the single script. So we'll say Python in place of, okay, now it can take, I think. Where is- yeah, this one. This is the name. Use case one, help desk agent Py. Okay, this is our semantic kernel. You know, entire use case script is there. So let's run. Let's see if we are getting any error. Let's check because I have changed this API keys and everything. Let's see. Hope it works for us or not. Okay, then we will resolve it. Let's wait. So now we have got a response, right? So it is working, whatever we have given the, this keys. So earlier what we were doing, we were using open source LLM. Now we are using Azure hosted OpenAI LLMs keys and other values. So if you see, hi, what is the status of this one? If my agent is saying, if you are asking these questions, what agent is replying? The status of ticket is this in progress. It is assigned to the network team with an estimated time arrival of 2 hours. Can you see this one? Again, the user is asking, I am locked out. Please reset password for the user George. So what agent is saying, I have initiated a password reset for this user George. A password reset link has been emailed to you to the account, right? Again, a user is asking, is VPN working right now? And is email up to? The agent says the VPN is currently experiencing intermittent drops while the email system is operational. So, I mean, this is what our semantic kernel is giving us a response, orchestrating it and giving us the response back, right? So this is how it typically you can design. And if you're working on the use cases where you think that I need to build some of the native functions and kind of a customizable functions, then it is better platform because only semantic kernel gives you a lot of customizable uh, Python based framework kernel to work on, functions to work on. Okay, so that is why people where there is a lot of customizations work on this semantic kernel. Any question, anybody? Can you have a 10-minute break and then we'll come back and cover this autogen? Everybody? Okay, just take 10-minute break and then we'll come back and cover this autogen. Yeah. Yeah, okay. Let me share my screen. Let's start with, so we are done with this semantic kernel one. So let me share my screen. Everybody is back or what? So, is my screen visible, right? Can anybody confirm if it's visible, right? Is my screen visible? Hello?
Yes, sir.
Yeah, okay. So we have seen this prompt native functions plugins. Okay. So they are just a code that I have explained to you. Okay. So when to use typically this semantic kernel. So when you say, at what place, for example, if you have some of the applications, okay, so you want to just add these plugins because it gives you flexibility of this native functions creations, native plugin creation. So in that case, you typically use it. And if you need some of the governance framework, right? So at enterprise level, it's a governance that is more important because if there are more secure applications that you want to work, so in that case, you need to have this, use this semantic kernel. And if you want to expose business logic as reusable plugins, because there are times if you're working with some of the CRM, okay, customer relationship data, and you're working on some of the custom business logics, it's better to use semantic kernel, okay? And there are a case where you need RAG planners tool calling in one SDK. So it's a semantic kernel, right? And let's say there are applications which are designed in .NET. So in that case, you use the semantic kernel, okay? And the popularity of the semantic kernel is again, it's a lightweight and modular. So again, this at architectural level, there is a modular code approach and lightweight because systems will have a less, a kind of space and everything, and also it will be fast. It's a model agnostic, so I mean it is not like a specific or restricted to some of the models, but can have access to each and every LLMs. And if you work on this production grade, okay, and want to add this observability that I was just talking about, so this semantic kernel will solve your purpose, okay. And also for this agentic or multi-agent, the tools or orchestrations, so semantic kernels serve our purpose. So I mean, again, it is more of, if I have to classify the semantic kernel, I would say it is more of a, enterprise level, the applications that, need in that time, that kind of orchestration. So if you summarize it somehow, the semantic kernel, because again, when you say plugins, it is nothing but it's more of a, the tools that we say. So don't get confused with the plugins. So it's again a tool. And kernel will behave like orchestrator. Okay. Planner plus memory, again, for dividing your goals and tasks, because LLM, once you give a prompt, LLM try to divide it. So what you need, some of the agents or some of the functions that can divide your task. So it's a planner and memory that has inbuilt in the semantic kernel that can divide your subtask. And as it is a production ready application, so I mean the semantic kernel is the first choice. It's model agnostic, means it is not dependent on only one model. So can have access to Azure OpenAI. If you see this one, okay, you can use this Azure OpenAI. You can use your Hugging Face, okay, and also for this integrations part. So if there are some of the applications which are already existing, can you integrate your semantic kernel Is it? Yes, you can. So, I mean, there are a lot of facilities that Semantic kernel gives you, but again, it is an enterprise grade and looks a bit complex. Is reason is that they gives you custom plugins facilities, and that is the one I would say the greatest takeaway. And it's more secure than the other, agentic framework. So that is why at enterprise level, this semantic kernel is used. Okay. So now, if I switch to AutoGen, okay. So this is another framework that I just wanted to share some thought on it because it's last framework that I'm talking about. So it is again developed by Microsoft only, but again it's in open source, right? So if you see, AutoGen. So I mean the why, because of a lot of framework that we have discussed, but why AutoGen? Because uh, multi-agent framework is there and developed by Microsoft Research, and it builds app as conversations between multiple specialized agent. As I was just talking about, it can work as an orchestrator. Okay, but there are a lot of this. Uh, I mean the framework, agentic framework that work as orchestrator. But what is so special about AutoGen? Because it says specialized agent it can work as. Okay, they can each agent can talk to each other, can call tools, can run the codes and iterate the solutions. For example, you might have seen a lot of coding tools. So whenever you just give a prompt, they give you the code as well. So it's the AutoGen facilities you can think of. So what is the core strength of this, you know, this application? So reach multi-agent conversation patterns, human in the loop. There is something called user proxy agent. So user proxy agent is a kind of agent. We can call it as HILT, HITL. So it is called human in the loop. So, some places you might see that this term HITL, you might have seen it. So whenever it's something it is written, it's like a human in the loop. And the user proxy agent is something which AutoGen gives you, but other agent doesn't give you, right? So because of a lot of agents works on this autonomous part, but if you give a full autonomy to any of the agent, then again you have to think of this Noel Harari, the code that I have said, right? So for complex, okay, also they have this built-in code executor and tool use. So there are a lot of things in AutoGen which are inbuilt. Okay, that is why sometimes if our use case demands like that, in that case we use this AutoGen, right? And where we can use this for the complex collaborative and autonomous problem solving. But again, we have human in the loop. But other model doesn't have. You have to explicitly bring in the human in the loop. But here it is inbuilt one. Okay. So if you focus on AutoGen, it's a multi-agent. Okay. And this has some superpower agent that converts an act. So that is the some superpower this auto agent has. Okay. So now let's cross it. There are some core concepts that we need to understand when you are working on this AutoGen. Okay. So the something that first I need to discuss is user proxy agent that I was just talking about. What is this user proxy agent? It is again human in the loop. Okay. So you take feedback from the human. Okay. Then I'll talk about these tools. Again, you can create some of the native functions, okay, that this AutoGen can use. Then you have assistant. It is again LLM. It is nothing. It's LLM. Okay. Teams, that is round robin group chat, selector group chat, orchestration. So it is like a main manager that can orchestrate. Okay. Then you have something called terminations. Okay. So if you see, because of this user proxy agent, okay, so need some of the feedback from the user. That is why you see this approval. If I approve it, then it can go to the second loop. And model client is like a chat completions. Again, how your logic will be wrapped inside LLM so that you get a response back. So few things, the concepts when you work on this autogen, you come across these things. But the first thing that you will see in the Python code is the user proxy agent always, because this is the human in the loop, right? So this is something that you can see. Okay. Now, uh, let me cross it and go to the second screen. Okay. So how this architecture of this AutoGen looks like. So you can compare it with the other architecture that I have shared with you. So the something that I was just highlighting today for this AutoGen is user proxy agent, because this is the beauty of this AutoGen, that it has human in the loop inbuilt in. That gives that agent is already built in. Okay. And other agent is, for example, assistant agent, assistant planner agent. So there are the few agents which are already built in other, if you see these other frameworks, we are trying to create some assistant agent, some reviewer agent, planner agent. But here you have some of the agent which are already built in, right? Isn't it? You see that the brighter side of this AutoGen, right? So in that case, it surpasses all other agents. The reason being is, again, the first one I'll highlight is the human in the loop, because other framework doesn't have this human in the loop. Because if you are given some of the people autonomy, you also bring in some of the check and balances. That is the best part of any humans to grow, because if you give 100% autonomy, they may go deviate their path, right? So this is the beauty of this autogen. So the few terms that was there on this screen was something assistant, something called user proxy. So let's discuss this one. So two agent chat, assistant plus user proxy. Okay. These are the patterns how you can develop this autogen. Okay. Can be a conversation patterns where there are multiple agent. There would be orchestrator who can speak the next. That is a group agent. Round robin is something the agent take deterministic turn in order. Deterministic means something which are not probabilistic. Okay, that is a deterministic. Means you are very much sure of. You are very much sure of that the my LLM gives a response like this. So other LLMs or any of the LLMs gives you probabilistic results. So that is a non-deterministic. Means if you ask same questions to LLM, they give you a different response. That is a probabilistic response. That is a non-deterministic. But if you having this approach, autogen, inside that autogen, round robin incorporated. So in that case, your autogen will give you deterministic result. Okay. And that is the ask or this enterprise level, people do this, they typically look for this deterministic result. Okay. LLM again, selector is again for the human like response you need to have, and some critical or critic agent. Okay, so they will review and improve it. Okay, so these are the some of the patterns that we typically follow it, and this is some of human in the loop due to these conditions you typically see, right? So this is again one of the two complex agent that I would say. One is semantic kernel and autogen, and if you understand their uses, you can use it. Okay. So, I mean, again, you are not working on any of the complex use cases, but industry uses a lot of autogen and the semantic kernel due to their security and human in the loop if they feel like to add this one. So again, coming to the use case. So let me share my screen. The use case part, and then you'll see that the what use case we can solve it through this autogen. Okay, so if you see this autogen part, so in this autogen, okay, what we are trying to solve, this is the use case. Okay, so here it is a multi-agent autogen. Okay, So two agents collaborate on Azure OpenAI because I'm using this Azure OpenAI. There will be one planner and one is reviewer. So one assistant can use a tool, currency converter, and second agent plan it because again we are seeing it to review and plan it, right? So they run as a round robin chat group, okay? And a stop when the reviewers say approve after having a maximum number of messages. Okay, so these are the way to install it. But we are using this to planner and reviewer. So need the framework that we are using is round robin chat. Okay, so let's see if I go down. These are the some libraries. Okay, that I have used. If you go down, the requirement.txt, if you see, there are two, this requirement, autogen chat and this autogen text. Okay. So again, let me go here. These are the libraries. So if you go, these are the sum of the modules, okay, that you require. Now coming to this one, these are again our modules. Taking from our library, autogen, we need an one assistant agent. We are importing it. This is again our, you can say the class, okay, this one importing from this module. Again, what other things which are importing is maximum message terminations, text mention terminations. We have to terminate it also. And the strategy that we are using for this is round robin group chat. And there is something called console. This is again one class. Okay. So what console will typically do? Consume the message from run stream and render the message to console. That is what we require this class. Again, this class, why we require this one? Azure OpenAI chat completion. This is a LLM. Because whatever output will come, need to pass it to our LLM. So these are the libraries and classes we are importing from Autogen, right? Now, the endpoint that we were talking about, the same Azure endpoint that I'm using. So I'll copy paste it here. So don't worry, because I need one LLM. The logic, the agent I'm taking from Autogen, that is done almost. But we need that whatever agent will work, whatever output they will bring into my table, I want end user to understand. For that, I need one LLM. And where LLM is sitting right now, LLM is within my Azure OpenAI. Okay. So now if I go down, so this is the definition converter. This is one function. Okay. As we are going up, there are the two, you can say the agent we are working. One is planner, one is reviewer. So if I go down, so this one is one functions. What these functions will do, this agent will do. Okay. This currency converter will take the money, the amount, and it will convert. So there are two, variables we are passing, parameters we are passing, amount and rate. It will convert. Okay. Then we are having this async def mem. So whatever Azure OpenAI, the LLM calls, we are doing in async def. This is again a functions. And then it's teaching this planner agent and the reviewer agent. There are the two agent. Okay. This is assistant agent. Planner is again an object. Okay. It's a variable. And we have this module. Okay. This entire class that we have imported. Okay. And inside that we have different functions. Okay. So this is a message and we have provisioned it. This is the planner agent. We have defined it. So what it is taking, the tool it is taking is currency converter, which we have defined it. Okay, currency converter. And this is again a tool we are seeing. So whatever logic we have written it here, currency converter, we are passing it to our planner agent here. You can see the tools and model. So model will interpret and this converter will have this logic holding and giving this prompt to our model because how this model will behave, right? How this agent will do, this planner agent. So we are saying you are a travel budget planner, use the currency converter tool. And if you get any money, right? So you have to convert it, right? Something like this and present a short, clear and budget breakdown or something. So we are giving instructions to our planner agent that you have to behave like this kind of a persona, right? So if I go down, we have also a reviewer agent. Okay. And this reviewer agent doesn't, we are not passing any tool. If you see this one, only the model, you can say, LLM you are passing it. And what we are saying to our reviewer agent that you are a reviewer and planner's budget for correction of clarity. If it is correct and clear, reply the exactly the word approve. Otherwise, give one shot specific corrections. Okay, so this will give you a reviewer, a persona that you have to do like this. Okay, and again there is something called approver. So this is a terminations that we were talking about. Okay, if you say approve, then it will terminate. And the strategy that the chat strategy that we are using is round robin. And how this round robin and giving the team task. So how this team variable it will work. Okay. So round robin is a strategy. So we are assigning it to this. So what this will do? So we are saying a traveler, a kind of a task. It's an input to our AI agent. A traveler has, let's say, 1,200 USD, and we have to convert it into euro. Okay. And we are also saying the rate is 0.29. Okay. Let's say for one of the USD is 0.92 euro. How many euro is that? And suggest a simple 3-day budget plan split. Also, we are saying convert it and then give us a 3-day budget plan also. Okay. Now we have to do await async because we want our response in console. We have to close the client and then you start it, because if you put it, then the application will start. Okay. So this is the entire flow, the coding of our AutoGen. Okay, hope you have understood. It looks similar to Crew AI, but have some of the differences. So let me take all the keys and everything from this so that it will be easy, not take much time. Okay, and pass it to AutoGen. Let's see if it works for us or not. Control V, Control S. Okay, and then create a separate terminal. Let's have this separate terminal. Requirement AutoGen, where is my screen, right? So take a separate terminal. Okay, you'll have a separate terminal. Let's scroll up a bit. Okay, now directly run it. Okay, let's see what happens, right? AutoGen. Okay, now we are inside this virtual environment. So directly we are running because our code is use case 3, AutoGen Python 3. Okay, so let's hit it. So once you hit it, let's see if it works for us or not. Okay, so hope it works because we have passed this key and everything. You'll see. Just wait some seconds. Okay, now we got a response. Let's see what response we have got. Okay, one scroll up. So if you go up, what it is saying, okay. So text message. So a traveler has this USD, again the task that you are seeing, and the prompt was to suggest a simple 3-day budget split. So this is the planner agent. Okay, this has converted amount and this everything. So you are seeing that how these are being executed, all these tools and everything, planner, planner, and planner. Okay, now if you go down, budget friendly. So finally we are getting this reviewer agent, because whatever coming from our planner agent, this reviewer will give you the review and create this 3-day budget of whatever it was saying, right? So the daily budget, it is saying 11,004 or something. So you'll have this 368 rupees, or let's say it's in euros per day, that you have to you can spend, right? So suggested split for days. So they are saying for accommodations, just invest 150 euros, food and drinks 100 euros, and other activities 118 euros. So they have given you the breakup, right? So it's like a more of a budget friendly within the budget they have given. And right. So the autogen, I mean, again, have some of, you can say the pre-built in agent already there. So based on that, we have created this, the entire flows, you can say. So just look at the, things that I'm just trying to explain. I mean, so once you have, systems where you are trying to design where you need some of the human in the loop and to have something which are already built in, because in this autogen there are few agents which are already built in. Okay, if you compare with the other framework where you have to work on to create some of the specialized agent, but here we have the plugins, or you can say agents which are already built in. So that is the facility of this autogen, I would say. So depending on our use case, again, I'm just trying to iterate it that you can create this entire systems, agentic AI systems. Okay, but again, this semantic kernel and this autogen looks a bit complex. The reason is that a kind of autonomy, kind of customizations that it provides. Okay. Any questions so far? Anybody? Anybody? Any question?
Sir, is semantic kernel and autogen used together, or are there any differences where should we use which?
Can you come again?
Sir, I am asking that is semantic kernel and autogen different, or they are used together?
No, no, no. These two are the frameworks. Can't be used, together. It's like a different framework altogether. Okay. So to give you the answer of your questions, I have this entire PPT. So when and where to use, right? So semantic kernel, you have to give priority when you are working on this enterprise app integrations, and you have to work on different plugins, different custom tools. Just think of, I'm just giving you a situation, then you will understand the word plugins. Okay. So for example, you have 5 data sources or 5 CRM that you are using, customer relationship management, and the data is from different data sources. So in that case, it's better to create different plugins. Got it? So in enterprise level, if you work, data is not sitting at a one place. It is not from one source. Have the multiple sources of the data. So, uh, you know, uh, in that case, client needs some of the applications or whatever you call it, where they have this plugin facilities where they can create a custom tools. So in that case, use this semantic kernel. Okay. And it is saying, the when to use. So adding AI into existing products and applications, and if you need this governance or something. And again, semantic kernel is lightweight because of this custom plugins facilities. Have this model agnostic, can connect with any of the LLMs, and can have this filters and telemetry, again, for example, for observabilities. So more secure semantic kernels are the first choice for enterprise grade applications in healthcare. If you see in the finance, people use this semantic kernel more because of the security and flexibility to play with the plugins, kind of a Python script, right? Autogen, if you have this conversational, flow that you want some customizations, complex task it is saying. So, I mean, Crew AI in Autogen, I would say, depending on the situation, you can use it. But again, as I was just explaining this human in the loop, if you want to bring in, then Autogen is the first choice. Okay. Now, Crew AI, if you see this Crew AI, it's a role-based agent. Okay. So, I mean, if you have a multi-agents and you are very much sure of that this agent will do this task. So just think of it as a structured teams with clear roles. I mean, you are very much deterministic that this person will do this, and the clear roles, clear visibility. If you have, then go with this Crew AI. Okay. and if you have some sequential task that you want to perform, and there are less dynamism in your applications. There is a no twist and turns. There is a no non-linearity. It's like a linear flow. Like you do task A, and then you can switch to task B, right? If there are dependent tasks, in that case, go with this screw way. So as it is saying that the role based and have this role clarity and have this sequential task, then go with this screw AI. But the Lang graph, I'll rate much higher. Reason is that it is stateful. And if you have some of the non-linear flow in your use case, have multi-term, but still it gives you a deterministic result. The reason is that it is stateful and have these nodes and edges. So that gives the autonomy of this Lang graph. Okay. So that is why we'll see a lot of 80% of enterprise applications are built on Lang graph because of this deterministic one. The word deterministic. The reason is that because LLMs hallucinates. So is there any way that, because hallucinations means it is giving you factually incorrect answers. Factually incorrect means it is giving you probabilistic answers. For the same prompt that you, if you are 5 friends, may get the different responses. Okay. But when you design this Lang graph, probability of getting the same result back is something called deterministic. So the probabilistic and deterministic is something that you have to make balance of, right? So that is why this Lang graph tops all other agents, right? So rule of thumb, right now it's below semantic kernel. So if you have to integrate AI into applications, so go with the semantic kernel because you can use modular, reusable plugins, functions, tools. Autogen, when you have to converse with different agents. Crew AI, when you are very much sure of the roles. LangGraph, when you have precise control over the state. State is nothing but some memory, right? So if you want applications that is memory based, it's better to go with this or this LangGraph. Okay, so this is the entire framework that I was just talking about, where I mean we are able to cover these 4 frameworks now: semantic kernel, autogen, CRUA, and LangGraph. And each frameworks is solving a different and unique use cases, which you can also work on. So this entire, this table will give you insights of that when to use and why, because if you know that the when to use and why, right? So that will gives you more clarity, because again, semantic kernel, sometimes you can use it, sometimes you can use the crew AI, but if you know that the where you can use, because if you have different, tools, techniques, you cannot use it for the same task, right? So you must have a clarity that where I can use it, these all tools and techniques, right? So yeah, again, you can use it. So this all frameworks we have covered. Any questions, anybody? From any of the sessions, if you have. Okay. Any questions so far? कोई क्वेश्चन नहीं है? No questions, nobody, right? Good. So now there is one small topic that I want to cover within this 20-25 minutes. Allow me 20-25 minutes. I don't want to bore you people. But again, it's important for us to know, right? So if you see this, LLMs that we talked about, right? So, I mean, the framework that we talked about, the different framework, all the 4 frameworks that we were talking these weeks, and we are able to cover those 4 frameworks, which are very much important. So, and also one of the Azure cloud that we have covered. At least you know that how we can navigate and have those key and use it in our Python script. Even if you are able to do that, you are good to go as a freshers, right? So the something called a framework that I want to talk is deep eval. Okay, how you going to evaluate your LLM? Because we were now concentrating only on the responses coming from the LLM, and we are very happy that okay, something we are getting from our LLM. But what LLMs tells you, it's not about that the LLMs giving you a response are correct, factually correct, right? But how who gonna evaluate it, right? So there would be some framework that you must work on. So if you work on any of the use case, it's better to use this, the evaluations framework, so that you must be sure of that the responses that you are getting are accurate and very much reliable, right? Because you cannot work on any of the production grade agentic AI systems unless and until you have this evaluation framework integrated in your entire systems, right? So how are you going to test your LLMs? That we will talk about. But it's a small PPT and I will not take much of the 15 to 20 minutes. Let's concentrate on this. This is very much important, right? Okay. So when it comes to, why we, because when we use this LLM, right? So it's not like your work is done, right? As we were discussing about these LLMs, okay, they are non-deterministics. So when I say non-deterministics, what does it mean, right? So non-deterministics, whenever you see non-deterministic, it means they are talking about something called probabilistics, probable answer. So LLM gives you probable answers, right? For example, you are the same person. If I ask you the same questions and you are giving me the different response. So are you probabilistic or deterministics? Right, you are probabilistics because you are giving me the response in I am not sure of that what response you will get for the same question the third time, right? LLMs are mastering that. In some case, if you are not giving the prompt wisely, right? Even if you are giving prompt wisely, they may still deviate. They may not give you the grounding response. That is the reason we need to evaluate LLM outputs. Okay. But what is the risk in the productions? Factually errors, that is hallucinations. They may give you these irrelevant responses, which are off topics. Even if you have this RAG pipeline inbuilt, even if they give you the wrong context responses, more of biased in nature, unsafe content, toxicities, something which we all struggle with when we implement this entire RAG, agentic AI, any of the AI systems in place. Sometimes it looks fine, but not measurable or repeatable metrics. We need to regress this testing. There is something called regression testings, and prove a model. This prompt or model change did not break the quality of your AI systems. So what could be the goal of, again, the deep eval is to quantify accuracy and reliability. Because if you putting your entire AI agent application into productions, how can you put it into productions without evaluating the LLM performance, right? So if you are without evaluating, so you are sitting blindly, no quality signal is there. There is a silent regressions. But if you are using this framework, you have this measurable output at least. You can test it, give some scores, have this CI/CD. If you have the CI/CD pipeline, you have this kind of a checks and balances, kind of a quality gates. You have to pass the output to deep eval, okay, and have this confidence that when you deploy the applications, you'll have a confidence that okay, my responses are coming from this deep eval and it's more accurate and reliable, right? So this is what the deep eval will help you when it comes to the production grade applications. Okay. So now clear my drawings. Let's move to the second slide. Okay. So about this deep eval, it's again, I would say, like a open source LLM framework. Okay. And let's pull this one. Okay. it's like a PI test for LLM. Unit test you do with this LLM applications, okay? Runs locally, integrated in CI/CD, okay? End to end, you can evaluate. Component level also you can evaluate, and can use as LLM as a judge, right? And can give this human like a response, okay? So this is the deep eval framework can do for you. And this is for this LLM testing that I was trying to explain. If you want to bring some of the confidence so that the vendor can trust your entire applications, then it's good deep eval, you must integrate it. And the superpower with this deep eval framework is that it's metrics oriented, okay? And this PI test integration is there. So that makes, deep eval, one of the finest framework that we have to work on, okay? So now, so the core concept, if you see, the few things that you must have to have in place, something called, the first one I'll talk about this metrics, because if you have deep eval integrated in your agentic AI systems, it gives you some of the scores or some threshold, okay, whether it will pass or not. For example, if you have a prompt and you are getting a response, whether it is passing from this deep eval or not, because deep eval will give you also some of the few shot, you know you can say zero shot, right? So that can help you also, and it gives us a response in terms of a matrix. So this matrix will help us. Something called golden data set. What is a golden data set? Typically, we have some of the input and expected output already defined, that we call it as a golden data set. So whenever you run this deep eval test, it will check your golden data set. And these are the some functions. If you see these evaluate functions, you'll see in the Python script. Assert test, PI test style assertion test function. These are the two functions. Synthesizer is auto generate synthetic test data. Okay. From golden data, if you want to create some synthetic data, you can create. And LLM test case. So what all LLM test case it can perform? Input, actual output, expected output, and retrieved concepts. And based on this, it gives some matrices. Okay. So deep eval, again, framework. It's don't look at in isolations, because again, your system, how to make your systems explainable, interpretable, right? Because again, the LLMs, whatever we talked about in these weeks, we talked about the black box. LLM is nothing a black box, but deep eval is one element that will unbox your black box, right? That can bring trust among your vendors, because if you say your vendors say that the response I am getting, can you explain it? Cannot explain it, cannot quantify it, right? So it's a deep eval that can come to rescue you, that okay, this is the region that your system is giving a response. You'll have some metrics, some numbers, right? Some scoring mechanism would be there, right? So that is a deep eval, right? So clear the drawings, and let's move to the next slide. So deep eval, for example, how we're gonna integrate it and the flow that we must see, right? You should see also in terms of this, adding this as a flow, right? So let's see. Let's see. We have some of the applications that you worked on. Let's say it's a RAG or agent framework that you work, right? So how, as it is saying, turn any LLM output into scored repeatable test. Same output can be measured on multiple metrics at once. That is what deep eval will work. Okay, and what would be the evaluation flows that we are talking about, right? So let's say we have the agentic AI applications that you build. Then you do this LLM test cases, right? So you pass it this your deep eval through this input, output, and retrieval context. And the matrix we look for is relevancy, faithfulness, G-eval, and biasness. There are multiple matrices we can look for. Then we have LLM as a judge. Then it can score each matrices and give this 0 to 1 like a score. And whether this, passing or failing, this is also, it is being mentioned here. So This deep eval, okay, gives you the the entire confidence in your AI systems end to end. So this is a kind of interesting framework people don't talk of, but it's more important. Now, coming to some of the matrices categories, okay, you people can also work on. RAG quality is there, right? So if you see this something called RAG quality, okay. So RAG quality is there. So let's say if you're working on the RAG, then also work on the relevancy, faithfulness, how precise response is, relevance, whether it's relevant or not. There is a correctness, okay. So whatever prompt you have passed, whether it is aligned to it or not. So this is another metrics. Safety and the biasness or whatever you call it, how much safe your LLM response is, or entire system is. For example, the response we are getting is more kind of hallucinating or biased. Is there any PII leakage, means personal identification, informations? Agentic task, if you are using this agent, then how much correct tool that you're using and how much your tool is working, okay? Whether it is giving a response which are correct or not. The conversational metrics, so the role adherence, the role that you have specified to your agent is matching to that or not. Knowledge retentions, whether from the knowledge base whatever you are retrieving is retaining it or not. And conversational completeness, the responses which we are getting are complete or not, or whether it's like in a midway the responses are giving you, and it's like a half response, right, that you are getting. And summarizations means, I mean, again, if you're working on some summarizations task, whether the summarizations which are coming from your LLMs make sense or not, whether it is covering the context or not. So these are the deep levels matrices typically we have. Okay. So how you typically implement this deep eval? Okay. So these are the, if you see kind of the framework, right? So let me take you to the, I would say, a coding part. Let me walk you through this. So directly, let me share my screen. Then we'll have understanding. Okay. So let me, how this coding will look for us. Where is my screen? 1 minute. Let me open this one. Let me go to this screen. Can you see my screen? This one, right? Share it. So if you see deep eval, there is something called deep eval. If you go deep eval, okay, deep eval examples.py, okay. If you see this one, just see this code. So deep eval, basically, we have this deep eval module, yeah. Let me hover it. I think it's not working, right? So deep eval, okay. And these are the matrices that deep eval typically trying to give you, right? This answer relevance, faithfulness, GE eval, hallucination matrix. And from where it is taking, okay, this is again a module one. And this is the class, okay. These are the class it is importing, okay. If I go down, you can use it as a judge, okay. And also it is giving you the example. This is again a method, okay. An LLM test is there. It is coming from LLM test case, okay. And we are seeing input as what is the return policy, and actual output what we are expecting. You can return any item within 30 days for a full refund, okay. So it will review your responses, and then it gives you the score and the reason also. Yeah, if you go down, we have this second matrix called faithfulness. Then you have the same way we have calculated this, the first matrix, that is a relevancy. Then we have faithfulness. Then we have this something called correctness. Okay. And even the criteria for this correctness, we are giving it. Okay. So custom correctness, whatever you want to write it, you can write it. Okay. So these are the matrices we are trying to, calculate. So deep eval will give you this facility. Again, we are having this hallucination matrix we are trying to check. So there are different matrices we can check. Okay. So this is how you can work on this uh, deep eval matrices. Okay. So now let me again come back to deep eval directly, where I was. So this will give you a bit clarity. Okay. So you can run it deep eval. Okay. Now, if you go down, relevancy, everything that we have seen, it's again a functions, definitions within this deep eval framework in the Python that we have seen. Okay. Relevancy, okay, this test and everything. Okay. So these are also coming from our Python scripts. Okay. So the something which you see is reliability and safety, that we typically call it as a guardrails. Yeah. So as LLMs cannot work in isolations, so also you have to have something, some mechanism where you can keep eye on this hallucination also, biasness, toxicity. Okay. Because you cannot keep your LLM open, that it gives you the, the false claim, that is hallucination, actually incorrect response. Toxicity is that, let's say your LLM, someone has written a bad prompt. So also it is catching the harmful behavior. It is also giving you offensive response, giving you unsafe religion, language, kind of some abusive language. It is giving you a response, right? So again, you have to have this guardrail in place. So don't look at LLM as a isolated applications or systems or any tool, because you need to have this guardrail in place, because ultimately someone is going to use it. So how you want your application to be consumed, if someone want to use, if it is having hallucinations, toxicity, biasness, will people use it, and what will be the experience, right? So that is why the guardrails again at this ethical level, at governance level, it's very much important, right? So not it as a coding, you can code it, but have to have these things in place also, that whether my application agentic AI system is addressing biasness, toxicity, hallucinations or not. There are the people who typically call them as a red teaming people. So adversely probe the app for how vulnerable and jailbreaks, kind of a prompt they write. For example, in your, let's say you work in a organizations where you're working on agentic AI applications, you built it end to end. 4 or 5 people you were there, and now you want to deploy it in a productions, right? So there would be some of the red teaming guy from the responsible AI team. They will try to check the quality of your AI agent. They will try to write some malicious prompt. They will try to deceive your AI systems. Okay. They will try to see that the how vulnerable your application is. So they are the from your team only, but they are like, they will have this quality check, I would say. So the people who do all these things are, we call them the red teaming people. Okay. Red teaming typically we call it, because before you put your application into productions, must go by red teaming team. Okay. They're going to do this red teaming, and then they will be much sure that the nobody can deceive the systems, right? So this is the, one of the aspects that are more important that you people must aware of, right? So now, again, this customer support, everything that you can do. This last one that I just want to talk, there are, apart from this deep level, there are the few frameworks that you people can explore. I will be, sharing this PPT with you. So apart from this deep level, if you see this deep level, okay. So deep level is the framework that we have discussed. There is also RAG AS, RAGAS. So it's a RAG specific metrics that you want to catch. Okay. Prompt foo is one of the framework, one of the tools for the A/B testings. And if you have something in this, this YML configurations. Okay. LangSmith, the tool that I was just talking about, it's family of LangChain, LangGraph, LangSmith. Okay. For observability, if you want to evaluate and trace. So majority of the enterprise level applications, you'll see this LangSmith integrated because uh, they need to trace, observe, and evaluate. Okay. So these tools typically will help you also with as a enhancement to your AI systems because cannot see as a isolations, right? The takeaway is again for deep evals. Okay, there are 14 matrices that deep eval can handle it. Apart from this, accuracy, faithfulness, relevancy, safety, and more, right? And there is something called GEval, lets you define any custom metrics also in a plain English. You can also integrate this deep eval with CI/CD systems and have this result measurable output so that it's more reliable and accurate, right? So the entire deep eval is will finish the entire workflows of your AI systems because the evaluations, testing, red teaming, everything can be done through this one of the framework, right? So this is what I just wanted to explain. Okay, so any questions so far? Anybody? Any question? Anybody? I think everybody is exhausted, right? Everybody look for this lunch, right? So let's close today's session and let's meet tomorrow. So we'll have a light session tomorrow. So we'll talk, few topics, but I'll expect everyone to join tomorrow because Santanu sir will give you a guidance on your project and if any next course of actions. Okay. Any questions, anybody?
No, sir.
Thank you so much for responding. So let's meet tomorrow at the same time, and let's utilize that time. Okay. So everyone, I expect everyone to join tomorrow. Okay. So let's have and we'll close that session tomorrow. Okay. So thank you so much. Let's meet tomorrow. Okay. Thank you, everyone.